We know by now that a tune is a sequence of periodic sounds, but not just any periodic sound, but very specific ones that we call notes. Where do they come from? That's what this class is going to be about. Oh, the sound of music.
Let's start at the very beginning. A very good place to start.
Let's do as Maria says and start at the very beginning. By now we know that musical notes are periodic sounds and that each note has a different frequency. But have you ever wondered which frequencies are those and why? Which? That's easy. Here they are. Why? That story's a longer one. It is longer because it goes way back. We may start with ancient Egypt, not because it started there, but just because that civilization managed to document it in a way that it survived to our days. In ancient Egypt, the gods they worshipped were associated with numbers. According to Diodorus of Sicily, they believed these two gods, Osiris and his faithful wife Isis. She put him back together after he was murdered by his evil brother Seth, and his body chopped in 43 pieces. Osiris is associated with number 2, Isis with number 3. Egyptians believed that these two regulated the entire universe. Holy as the gods in numbers was music, and the first hole that was bored in a flute was done at 2/3 of its length. Let's build the flute to the pleasure of Isis and Osiris. We already bored the first hole. Our God-pleasing flute is already capable of playing 2 notes, one with the finger covering the hole. Notice the acoustic pressure at both ends must be 0, and the other with the hole open. Notice that the acoustic pressure of an open hole is also 0. To keep pleasing the gods, the second hole should go at 2/3 of 2/3, that's 4/9. Then 8/27, 16/81, 32/243. But wait. Look at the size of the hand and the size of the flute. That would not be an easy flute to play, and the fundamental is not the only vibrational mode available. Going back to the 4/9 hole, the same pitch can be produced by one of 8/9 if the second vibrational mode is excited. That hole can also produce this other pitch.
You're only multiplying by Osiris. Will Isis be okay with that?
Snow seal failed with one on
She says she might get angry if she's not allowed to multiply at least once. Let's do the same with the rest of the holes, and then we'll try to figure out how we're going to make it up to Isis. Showing the acoustic waves. Showing now the ones in 2/3 and the fundamental. Listen to the corresponding sounds when opening the holes in the order they were bored. The frequency increments in 3/2 from hole to hole. Musicians call these intervals fifth, and we shortly see why. We don't want Isis' wrath, so in the next hole there must be a 3 involved in multiplication. Say 3/2. But then we will run out of flute. How about 3/4? There. Good. Now that the gods are pleased, let's play the flute lowest pitches by opening the holes from the left to the right, starting with no holes being open. Have we heard that before? Of course we have. Here's how it would play in a modern keyboard. Well, about that fifth we mentioned earlier. The interval from the do to itself is a unison. The one with a do to re is a second. Do to mi is a third. Do to fa is a fourth, and do to sol is the fifth. But this goes on. Do to la is a sixth, the do to si is a seventh, and the do to a do is an octave.
What are the frequencies for do, re, mi, and so on?
There are no exact frequencies associated with do, re, mi. These are called grades. No matter where the frequency of a do is defined, a re would be at the second, mi at the third, and so on. Since 1955, it was established by the International Standard Organization number 16 that the la after the fourth do in the piano keyboard would have 440 Hz. Once the frequencies are assigned, the notes take names as shown. A3, B3, C4, and so on. The numbers indicate after which do comes the note.
What about those black keys?
There where it gets interesting. I'm sure Isis and Osiris are pleased with this flute. However, ancient Egyptian flutes had different design. A single flute was not built to play all the notes. Several were needed to play a tune.
Back then, it was either the music or the pyramids, and the musicians union made sure no one came up with a flute that could play all the notes.
Very funny. It is true that Egyptians believed in the holiness of numbers, but that fifth interval was not only pleasing their gods, it was also pleasing their ears. Consider the harmonics of a note of frequency F and that of another one making a fifth. Half of the harmonics of the second note reinforce those of the first. But the combination tones of all the harmonics, those create the sensation of another instrument playing a note at 1/2 F, and that enriches the sound in a magic way. Leaping over some centuries and the Mediterranean Sea, we are now in ancient Greece, and we find Pythagoras theorizing about intervals. Let's get back to our flute, but also indicating frequency ranges. These are the Pythagorean intervals. 5 intervals in the octave are 9/8, and those are the Pythagorean tones. There are 2 smaller ones, and those are the diatonic, or Pythagorean semitones. Another 5 elements in the progression of the fifth, that's multiplying by 3/2. And we get another 5 holes to bore. The new holes are not even possible. So as done before, we bring the holes to the left half of the flute. There. The 5 new holes correspond to the black keys of the keyboard. Say the lowest note of the flute is a C. Then the new keys are C sharp, D sharp, and so on. It seems as if the Greeks had figured it all out. They were even aware of the limitations of the set of notes they had so mathematically defined. However, solution to those had to wait a few centuries. Next class is about these limitations and how they were solved with temperaments.